You have a nightmare over here for some people. Some people, this is easy. You taking calculus. When we go over this, remember that this is not 4.5. This is telling you to square 4 and by a half square. And this is saying take 64 over you're going to do the fifth root of 64 times 6. That's what this means. And we're going to go over soon what you do. Now, remember, you have to keep everything under the radical sign, and that is this here. If you don't keep everything under the radical sign, you're going to be in trouble. Let's move on. Now you have these roots here, and we wrote them. Remember, I said this is what these are. These are 4 to the half root. Your radical sign is here. A lot of people get this confused, and they want to take the 6 here. And let's just be honest, sometimes I do it myself, and they want to make this 6 and 5. That's not right. This, you have to keep what's going on. It's the fifth square over here times the sixth root, and the sixth root is really going to be 2. You can also keep it at 64, but I just wanted to show you that 2 times 2 times 2 times 2, 3 times 2, 4, 8, 8 and 2, 16. 16 times 2 is 32. And 32 times this last 2 is going to be 64. So if you go ahead and you do this, you can now go on ahead and keep your fifth root of 2 here. Or you could keep it fifth root of 64. It doesn't matter because you want 5 roots. But just understand what's going on. Okay, now I put it here 2 to the 6th root. It's here. We did it again. And when you get ready to do, this is 64, but because you have this 5th root here, you still have to take care of that. So now you've got this horror. And remember, this means 2 here and the 1 here, which means absolutely nothing. This 1 over here is just doing something, and 1, that means nothing. These are all 2s. This 1 here is playing with you. This is 2 to the 2nd root, 5 to the 2nd root, 2 to the 5th root, square root of 4. Why is that? Because this half root means take 2 to the 2nd power under a radical. If this was the number 4, you would put 4 over here. It's not. So leave it and just try to play this video back until you understand what's going on. So this is square root of 4, which is equal to 2, and this is 2 to the 5th root. Why is that? Because the 5th root of 64 is 2, but guess what? When you get ready to do all of your 2's, you're going to have an extra. Because 2 to the 6th power is 64. So you're going to have a 2 by itself. Aha. That's the problem. This is 6. This 6 2, so this 2 comes out, and that becomes 1. This 2 comes out, and then 8, 16, 32. This 2 comes out, but this becomes, and all of them get together and cancel, and they become 2 to the square root of 2. You have to leave it there because you have 6 here to get to 64, but this says only 5. So one of them has to be alone. We chose this guy. Last guy out. Last man standing. This 2. You have to leave him under the radical. He's by himself, and so that's where he shows up here. I'm overemphasizing here, but he's a 2. Sorry. Erased it. He has to be by himself. So he has to stay under the radical, and here he is. Now, some people will go ahead and put this here, and they'll go ahead and say, let me cross this 2 and this 2 out. You have silly rules in this kind of algebra. This square root of 4 equals this 2. We already went over how you got to 2 to the 5th power, which is 2 because you had to leave this 2 alone, and now you have to rationalize the denominator. But I went ahead and divided these into each other so you'd get 1. And when you got 1, you still had over here 2 to the square root of 2, and over here you had square root of 2 times square root of 2. Now you can only do like terms. So you can only do this like term with this like term, which then becomes this square root of 4 times this 2. Forgive me, this 2 is gone. Now you can cancel these out again. Becomes 1. 2 divides into itself. You put this 1 here. This is the square root of 2. You cannot do this. You can put the square root of 2 is approximately 1.44, but we're trying to leave it as a fraction, so you just leave it here. And then this is 2 times this 2, which is, what's the square root of 4, guys? Early stuff, 2. So 2 times 2 is 4. 1 over square root of 2 times 4, and that's your answer. 2a to the half power times 5a to the half power times b to the half power times all of this 5a to the half power b to the 4th power squared. This is a mess. Let's look at how we do it. This 2 over here that's over the half goes over to this sign. This becomes a squared root. Here's a squared root is implied over here anyway, but for right now I kept it there so you could see what it is. I kept it here so you could see what it is, so you could take it out and make it 2a's. Because if you see it like this, you then know to cross these 2a's out. Okay, then you had a 5. Now, like numbers are going to multiply by each other, but here's the situation. This whole has to get multiplied by this whole. Okay, so we have 2a. These 2a's come out, and you get this a. And then you have 5 squared. I took this square, put it here for 5 squared so you don't forget. These 2a's come out from underneath this, but then it's a squared from this square. This square goes here. See, that's what makes this a mess. You have to realize which square is which. This is 4 times this square over to this square, and that's what makes this such an awful problem. Okay, so when we move on, we have 2a, 5a, still to the square, b half square, and here's the situation. We took them out and we multiplied, and we got 2 times 25, 50a. Now you still have to have your a over the second root was over here, and then you had this b times the half root. So what ends up happening is you have 50 square root a to the third square root to the b. This was the one that was over here as a half. So this 2 doesn't need to be there. This 2 doesn't need to be here. Guess what happens? A times a times a. You already had an a over here. You already had an a over here. They come out, and they come out from under here, and this one stays under the square root. And this square root over the b stays over here. Okay, now make sure that you understand that this b to a half and this one too, the 2 on the bottom comes over to this 2. And this becomes the square root of b times 1, which any number times self equals square root b. So now let's look at this monstrous mess as we had done before. We take the A3 out, the A's cancel out the A. This A comes over here. This A remains under the square root bracket. That's what happens here. And this B is just a regular square. You put the 2 here as a principal, but it doesn't matter. You could leave the 2 here. You could combine them because they're 2 variables. Or you can also do this. You can also leave them separate. You can also do equals 50A square root of A square root of B. And that's your answer, either one of these. Okay? X to the 1/3 times x to the 1/9 times 6 squared divided by x to the 1/3. Here is what you do. You have a powers rule. You add the powers. Because they're inside a bracket. And then you multiply whatever this answer that's inside the bracket. If you had this, then if you had a 6 here, you multiply. So we're going to go through this. X to the 1/3 times x to the 1/9, all of that times 6. Now here's the thing. You're adding powers. Powers are getting added. So you have a different denominator, 3 and a 9. So 3 and a 9 you have here. You have to come out and get 4 over 9. Many people are tempted to say 1/3 times 1/9 equals 1/27. Okay, so now you get 4/9. And so now you'd have x over 4/9 under the bracket of 6. Please be careful and pay attention to what I'm doing. Try to look at the math. I just went ahead and did this and I put the 1/9 here, but you didn't have to go through that. It was redundant. 9 is your bottom denominator. 9 goes into itself one time. 1 is here. 1 times 1 is 1. 3 times 3 is 9, so you want this number to go into this 9. And I put the 3 out here. This 3 goes into 9, and I put the 3 over here, and this 3 times 1 is 3. I always teach the kids to think of what goes here, and then whatever this number is, you multiply it here, and you make kind of like a loop. So you go here with one loop, and then you go here with another loop, and so you get 3/9 plus 1/9 equals 4/9. So now you have x over 4/9 and the whole thing times 6 raised to the 6th power. Okay, we went over that. Now, you have divided. A lot of people are going to be tempted to go on ahead and write this equation out and put the divisor under here and go x over 1/3. You can, but maybe you shouldn't. Okay? You don't have to. This is x. You go 6 times 4 is 24 over 9. Now, doesn't that get reduced? Like 3 goes into 9, 3 times 3 is 9, 3 goes into 24, so that's 8. So that's x over 8/3 divided by, and what do you do here? When it's division, you subtract. So we're subtracting the exponents. Times 7 to the 3rd, you remember you take the bottom and you put the 3 over to the you make it the radicand. And then the 7 is what actually goes under the radical sign. So you have, again, cubed root of x raised to the 7th power. Now, 6 plus 1 is 7, cubed root. Now what can you do here? 6 divided by 3 is 2. So 6 to the 2, that takes care of that. But you have 1 left over that you did not take care of. So guess what? What are you going to do? You're going to leave it under the radical sign. So that's how I got this nice little number, because this 6 divided by this 3 equals 2. So that's how I got x squared, square root of x. And this is your answer. A lot of people will say, why didn't you do x times x and do 7? It gets complicated because when you start doing x to the 7th, as I had told people to do before, okay, you have 7 here, but you have a cubed root. So this gets complicated. You have this root, and you have this is left out, and you see that this stays under. But here's the funny thing about this and why you have to remember this, another stupid rule. You have 2 sets of x's coming out. So people say, okay, fine, but it's 2 sets. This represents 1 set. So you can't just do in only this set here. So you have to do something to represent that set, so it's x squared. But a lot of times people forget that. So I say go ahead and see if you can break this exponent down and do it that way so you're not forgetting what happens.